this point it's not like the smoothest of intros. The idea was to be like plug and play, and as Martin said, it never works like that, and this is not working. So let's say that we have the hardware, but we don't have the software yet. And I partly I have blame Oculus, have blame Microsoft, Windows, and have blame I don't know everything else because it's a nightmare. Anyway, I'll keep an eye on this. Maybe I'm a bit distracted, and what I wanted to talk about is a bit jumble right now, but let's go. Yeah. So my name is Jaume Sánchez. I'm this byte on Twitter. This is an update to a talk I did at Full Stack conference last year, and the update is the road to WebVR 1.0. So it's the second version and it's the 1.0. So we'll get to that about why the WebVR 1.0 is important. About replacing your reality with JavaScript. So yeah, yes, as Paul said, I work for BeReal. It's an agency, advertising agency, and we do lots of interactive experiences online with WebGL, web audio, and recently there's been some interest in WebVR, even though obviously it's still a very not mature technology, but we've done our explorations. Also in my spare time, I have my website, Click to Release, where there's lots of experiments, posts, and libraries, and all that stuff. Post the links afterwards. So I'm going to do a brief history of virtual reality. Maybe I don't know how many of you are aware of all the story in which we are and why things are how they are. I'll try to be succinct. So basically, when we talk about virtual reality in the sense of technology, we have not a clear term for that, of what it entails. It's basically a familiar umbrella term of everything that we know that it works, or how it should work, from movies, from books, from comics. That's what people are familiar with, and that's what kind of the industry is trying to go to, at the same time discovering new stuff that we didn't foresee. Like the better the hardware and the better the applications become, the more challenges we find that we need to solve that were never an issue. Which creates this dissonance between what the customers have in expectation of viewing virtual reality flying through incredible landscapes and the actuality that you get see, motion sickness. So we have to figure that out, and it's not easy because it belongs in part in technology, it belongs in part in patterns, and it belongs in part in performance. So let's go back to the beginning, let's say the 1980s. So I think this is one of the earliest images I've been able to find of what it was back then, and still, even though it's pretty crude and it's pretty raw, you can still see the elements that characterize today's virtual reality. You have the headset. It's a literally head-mounted display because it was cathode ray tubes, two of them in a helmet. They were so heavy that they usually needed some counterweight or some system of pulleys so you would be able to actually move around. And it was usually, it had sensors which would detect your position inside, so it wouldn't be any systems outside tracking your position. And then on these kind of weird things on the arms to tracking hands, tracking your gestures, everything was pretty like inside. So there were a lot of these kind of experiences built during the late 80s and the 90s. Same things with those heavy headsets. The graphics were kind of alright. It was more of about the whole thing, the whole futuristic, the whole discovering this thing. You know, it was growing in parallel. It was being evolved in movies and in reality. So we have this kind of situation in which you could feel that they were really heavy. It would have very high latency, so the speed from your movement until it was reflected on the environment, on the virtual environment, was really slow, which of course created a lot of motion sickness. Everything was very low fidelity, like it was literally like looking close up to a cathode ray screen, so you could see the skylines, you could see the components, the three colors that compose the graphics. The graphics themselves were really low in all sense, because the machines were not powerful enough. The 3D techniques weren't as much evolved as they are now. There hasn't been the GPU revolution yet, so everything was working on a very simple engines. But still, it wasn't that important for this to be really like low-fi graphics weren't that big of a problem, because if everything else works, you believe that you're in a world. It's just a world that's simply more polygonal or lower resolution, you know. But when everything responds, when you're immersed, then you can see that it works. So they built a lot of these kind of attractions or experiences, and they had exactly the same kind of problems that we're investigating now. I mean, it's changed the landscape of products and the availability specifically, but the problems are the same. So you would experience dizziness. They were expensive experiences because you basically had, there was no way this could be a home product. You had to go to arcades to play these things. You had to spend quarters on this. So it was expensive for people to have it. So they had to, so like the owners of the arcades had to have some return, and you would have to pay. They were usually 3-4 times more expensive, at least than the actual arcade machines. And of course, it was a terribly fragmented environment. You couldn't build something that you knew that would work on different VR rigs. So you would basically develop for one specific machine, or even build the machine directly. Were very close solutions. So this was kind of when everything was so hyped and it didn't pay out. This is where things kind of went now. So movies were, of course, pushing that, and all these kind of science and virtual reality and the philosophy and the technology. They never really went into the actual details. They were never really hard sci-fi. So that's why the expectations are more like, I don't know, in strange days, still people think that you can kind of read from people's mind and record their dreams, and then you can play them back. Like neurologists would probably tell you this won't work. You cannot map memories from someone into someone's brain. But maybe people have the expectation that at some point in the near future there will be like reading from someone's thoughts and putting them in full virtual reality. So that's the kind of things that they also have to be thought. So this was the first hype, the first wave. It never went away. Like most companies, not a lot of companies, but Sony, the military kept working on virtual reality displays, kept pushing the technology forward. This didn't happen suddenly because it was a new time to try it. It was basically sensors were improved, hardware was improved, it was miniaturized, better machines, better engineers came by. And then we got to the point of Lucky Palmer. I never remember his partner, Lucky Palmer. The guy from Oculus, anyway. He was working on his garage, trying to come up with a do-it-yourself virtual reality kit, some glasses, and trying to make it. I think it was by the 6th iteration. He decided he would put a Kickstarter out, so it would help people. They would buy the kit, and everyone would discover all these nice things that he was trying out. He felt that the things were close to the actual second coming of virtual reality. And then John Carmack was interested in, he was also in the meant to be seen in 3D forums. He got interested by this. He ran his own test on the latency, because everyone had still that perception from the 90s, which was like, it's slow, it's low quality, it's really laggy, you know? And John Carmack is known for knowing that you can do better graphics fast, and he was doing that. So he thought maybe in this period has also technology and hardware has caught up. And that's what happened. So he endorsed, he said, this is something I would like, this is something I find cool. And everybody went crazy because John Carmack was into that, so VR was happening. So Kickstarter, $2.4 million out of a 250,000 original Kickstart, Doom BFG edition for virtual reality, and everything was propelled. So we got to the first DK one. It's the one you were talking about. This didn't have any positional tracking. Positional tracking was just rotational tracking. So this is basically fancy cardboard back in the day. There was no cardboard yet, but this was very low resolution. It was pretty hard, but we got to do lots of interesting things with this. It had the big problem that if you move your body, your virtual image wouldn't move in the world. So that was in the beginning was like, is this acceptable? And we certainly said this is not acceptable. We need positional tracking. And then the improvements, DK2, which had positional tracking from an outside camera, the Crescent Bay prototype, the CV1, the HTC Vive, which is this one here, which has a different technology, but it's essentially the same idea. That there are some sensors, there's some stations or capture systems which tells you the position from outside. And yeah, this is basically kind of where we were a few months ago. Everything were prototypes, engineering models, CVs, and right now we have passed the release date when people have been able to buy it, been through the fairs and check all the different booths, different experiences. This is the classic image, so guy with a beard being, so. But this is not only Oculus or Vive, we also have the Samsung Gear, which is the idea that mobile platforms are becoming so powerful that you can actually run a lot of things there. And it's actually have almost everything that you need for a competent VR solution. So it's the rotational sensor is there, you've got a display, you have a flat display, you have a kind of a nice GPU graphics. And the Gear has this advantage over cardboard, which includes it's on the other side, the touchpad and the button, so that's solved. At this time, the cardboard generation 1 had the problem of the button. So this is basically what you can do with a Gear, for instance. It's a different aspect of VR. So there's the big, bulky, more expensive. This setup, it's kind of $1,000 or something like that. When it was the Note 4 with the Gear, it's still pretty heavy. But you already have the phone. That was the idea. Everybody has a phone. So if you can run with that, then it's good. It's got a Bluetooth controller, so it solves part of the locomotion via a controller. Then there's the new funny picture of the bearded guy. So cardboard, that was the really low-tech approach for this. Like we know that people have their phones. Phones are able to more or less show some compelling stereo. I wouldn't entirely call VR cardboard VR. It's more of a stereo panoramic which you can look around. But let's imagine this as responsive. A website can have lots of things like when you make a website, it doesn't need to have everything to be considered a website. So there's like the minimum probably in VR would be this stereo vision and some kind of fast response to a device orientation control. So that would be the cardboard generation 1. The cardboard generation 2 had the button, solved the problem with this is what Martin was mentioning is there's two magnets there which create the magnetic field. It had to be picked up by the system. The browser didn't do that. You had to do that. It wasn't really reliable. They came up with the second solution, which is the button, much better. But since there's still people with cardboard generation 1, when you design a solution for cardboard, you still have to think they won't have a button. So I still have to put some solution like stare at something, start a timer, and you can see, and then it's like a click. So basically, your controls have to grow in complexity and availability. So the next thing would be the Daydream, which announced in last Google I/O, and then you will have a clicker. You will have a device to click on. So yeah, that's basically it on the Cardboard 2. Then they integrated the sensor fusion. They actually didn't, because then they switched to the Cardboard 2, but it's the same idea. It's much better. There's no drift, or perceivable or lagging drift. It uses the Cardboard SDK in a much more, in a better way. So there's lots of things you don't have to do, like distorting everything. But the Android implementation of WebVR. Okay, let me try to explain something one second, because this gets a bit confusing. So you can render something in stereo with device orientation in a cardboard, for instance, put it on your eyes, and that's VR. But that's not the cardboard way. Then you can do it with cardboard, with the Cardboard SDK, or you can do it with the WebVR API, or you can do it with the polyfill that tries to fill the WebVR when it's not available. So right now, the amount of options to work with this are a bit over the top, basically because you have browsers which almost implement the WebVR 1.0 spec, browsers who implement the previous WebVR, so basically Chrome has WebVR 1.0 almost working. Firefox doesn't have 1.0 working until I think November. So the ones you're with is one with the last one. Cardboard, it's half there, but it doesn't really do the features that you would expect. And things like that. So it's pretty complicated. The thing is that for coding with JavaScript, there's a few tools that simplify everything. So I'm going to talk about the WebVR 1.0. I'm going to skip the previous WebVR API because it tried to do lots of things that weren't really the right thing, because at the same time, like Vive and Oculus kept on finding things and defining more of the spec. So there's more things outside the Vive, the Oculus, and this. There's the old Morpheus, Sony's PSVR project. This one works in a similar way. It's more like a DK2. There's OSVR, which is like your proper do-it-yourself kit. You can buy it. You can upgrade lenses and displays and sensors, but still everything is kind of falling into the same place. So how do you develop for VR nowadays outside of the web? You have Unity, you have the Unreal Engine 4, you can code your own things and integrate the SDKs. And what most people are doing is what I was saying, like the 360 video regular thing, an immersive experience, like our logic architecture visualizations, or gaming, which is kind of the big thing. So, what is WebVR? People sometimes are a bit confused about this. I don't know if it has improved the awareness, but is it the idea? Is like bringing VR content into the web? Is it a set of patterns that we have to follow to know how we can create a web page that is in virtual reality? Is it a browser that works in 3D? It's something that we install and then it will run in 3D and we'll see pages floating in cyberspace. So just to distinguish web space VR, it's VR content in the web. It's like something that you can put to images and then look around and it reacts. WebVR API, WebVR altogether, it's the API. There's a spec for this, just because sometimes there's a bit of confusion with people. So it's basically an API that enables the browsers to be a platform for VR using JavaScript. It's really cool. And it provides purpose-built interfaces to VR hardware to allow developers to build compelling, comfortable VR experiences. Okay. So, when they introduced, after finding that the original spec was a bit, had some edge cases that were really hurting the implementation, they decided to go with this. So, there's a specific need for handling the displays and the devices. Why is that? In the first version, you would basically be like painting on your browser, and that screen would go to the HMD. Problem: most of these systems run at 60 frames per second, and by the time they already know that the HMDs should run at 75 or 90, and now we're setting it on 90 hertz. So you first had a problem in which you had to basically overhaul, like modify completely Blink or Gecko in the browser, so they would run at a different frame rate from what you see on screen and what you see on the HMD. So that was not good. Traversing links in WebVR, also important. Nobody knows how to do that. There's, for instance, should there be a meta tag that defines that this experience is going to be VR enabled? How do we tell the developer that? How soon can you drop into VR mode so the transition is smooth? You're looking into a page that's in 3D. There's a link, that gallery with a model. You follow through. There's like a moment of loading that the browser takes care of, and then you go in continuing to another web page, another cyberspace. That's one thing that had to be considered in the API. So input handling, it wasn't good. Now it's dropped to the gamepad API, which works much better. Accommodation for the both sitting and standing experiences, because there's this big difference between Oculus, considering that the main experiences should be setting and then you can look around and kind of move in your area, or Vive, which proposes a room scale. And if you want to create your own experience, you have to be able to turn from one sitting position to standing position, and everything should be working. So they figure out that out too. And at the same time, suitability for desktop and mobile. So WebVR tries to create a common API for both, something you can build with Oculus or for the car, which is not an easy task. So what's the big improvement? What's the promises? Like, there's no need to install content components, so you can basically build the way you can stream assets. If you want to create an experience, Martin was saying, you don't need to download everything. Imagine you're building a game, maybe you don't need to download all the levels from the beginning, just to show the first level. You know, you can work with that because we have the power of downloading assets and controlling all the cache, everything that we already do with web. Can unify content from competing platforms, many devices? That's important too. If you get it, if you can make all your assets work vertically across the different possibilities of like a laptop or a beefy PC or a mobile phone, like Candyland. And especially that the URLs enable connectivity. So the big reach of the web, it's the big asset for trying to do this. You can send someone a link, and when everything is working, the browser will show it in VR. It will say like, put your glasses or step into this. Will detect when you put your headset, and then you will be there, and then you can start following links and doing everything. That's the promise. So yeah, this is the big part of the big place on the implementation. There's a very good documentation on the MDN, on Microsoft Developer Network. The spec it's on GitHub. It's very well detailed. And yeah, it was so Vladimir Vukicevic started. See, he was the one that created WebGL. He was working on graphics and games at Mozilla, and then decided to go through and bring VR. And then Brandon Jones helped, and they both created the first builds of VR browsers. And then Gilbert and Sivan from Mozilla have been helping and putting the spec to 1.0, like the modern one. And on WebVR.info, you can find all the information, you can have all the downloads, all the samples, and lots of stuff. Okay, I know it's dense, sorry. I would have lots of examples if this was for working, which would be much fun. Can we check 1 second if this is installed? Okay, so basically, WebVR it's quite simple. Not in the sense of basic, but it's a very limited number of methods and the way they work, which allows the developer to work with the VR hardware. So, first thing you do, you've got a navigator.getVR displays, which returns a promise. Then when resolved, it's a list of displays. Okay, so first thing, if there's a navigator.getVR displays, supposedly you have support for WebVR 1.0. Before that it was getVR devices, but forget about that. And if you have one and returns displays is 0, it's an empty list. It means that there's no devices. And if there's one device, pick one. Usually it's the first. You could have one. And VR displays, it's got several settings which are interesting, like display ID and display name, so you can know which one is of the several, or if it's an HTC, or if it's an Oculus, or whatever. If it's connected, which obviously means that it's enabled, and if it's presenting it's the concept when you're moving visual data from your laptop or your computer to the display, that's presenting. And then it's got a couple of structures, which are capabilities and stage parameters. Is this okay? I'm not ready. Just okay. Okay. Yeah. So, okay. Once you have your display, which would define any of these virtual reality displays, VR display capabilities. It tells you if it can present, which means that it has a means of showing what you want to render. Usually this would be yes. If it has an external display, this is important because it means that your device has an extra screen. So like for instance, the Vive or the Oculus has an external display, so you can keep showing something and redirect output to the HMD. but the cardboard doesn't, because it's a phone in which the main screen is the display, so it has no external display. Has orientation, has position. It's a boolean that tells you if it can have how many degrees of freedom has in tracking. So this one had both, and the cardboard will have only orientation, no position. And the maximum number of layers that this display supports. Layers is the concept that they've come up so you can composite correctly a VR presentation. So basically a layer right now in the current specification, it's one canvas. But ideally you can set several canvases and tell, okay, this is the main content, this is UI, this is notifications, you know, and the compositor will be able to tell how to put all those together. But right now, for now, it's one. And stage parameters defines for the solutions that have room scale support, it will give you the sitting to standing transform, which is a 16 element 4x4 float 32 array, which you can use in your calculations to move from the standing position, the sitting position to the standing position. And the size, the width of your area and the depth of your area. So if you want to make something that it's like literally tailored to the area which the user can move, you can do it with this, which is sometimes interesting. You don't have to worry about the things like the boundaries, because the Vive already has the chaperone integrated. So when you get close to the boundaries, there's this blue grid that shows you that you can go past. But if you want to make that chaperone match with your geometry, in case that you want to make something like your game, you can do it with this. So, setting this up, you have to create your transformation matrices for your 3D graphics, and you make it with the VR display get eye parameters, and you have to specify if it's left or right, because you'll have to create two different cameras, and with the offset, which is the distance from the center of the display to the center of the eye. That's the interpopular distance. With that distance, the field of view that is specified, which is a first term of angles, and the render width and render height, which would be the size of the display, the render type that you have to make to create the display. With that information, usually your 3D software, your 3D library, you don't usually build your own matrices or transformations, would create the right render target where you can draw. So then updating, like once you've got everything running, you want to update the position of the camera by using the get pose or get immediate pose method in the display. So basically, the thing is that the implementation doesn't say that you have to, like the browser has to do prediction. What they always tell you is like, try to get the pose as late as possible in your render, then render and try to present as soon as possible. Because if you get your pose really early, do lots of work and then present, there's going to be a lot of separation between what the user actually is and what you think in the simulation is in the virtual reality. So get pose will give you some estimation and will predict where the pose will be when you present. It does it by calling a bit earlier, so it knows like in a certain time in milliseconds it's going to present. So let's try to imagine that it's going to be there. So if you do that, it's okay. If you get immediate pose, it's the raw position or the raw rotation, and then you have to calculate if you want to do the projecting yourself, the prediction yourself. And basically what it gives you is a timestamp in case you want to keep track of where in time each position is. A vector free, so it's an array of 3 elements of the position, x, y, z, linear position, linear velocity, sorry, x, y, z, linear acceleration, x, y, z. So in each moment, how's the physics of the device, and in the same thing, the orientation, angular velocity, and angular acceleration are quaternion, so they're 4 component vectors. And with this, you basically update all your positions. And then presenting. So once you know that you want to, your base is able to present, you want to show something to the user in the headset, you first get your display instance and call request present with the layers. The layers is a struct in which you say which canvas are you going to be using for presentation. It's interesting because then you can have lots of CSS DOM elements on top of your canvas, but only the canvas is going to be shown to the HMD. So you don't have to worry about hiding stuff, hiding UI from the main page. It's a promise, and when it resolves, it means that you can start presenting. So the HMD is ready for updating every time you tell it to. And then that's one interesting improvement. When we had the previous WebVR API, you would be using window request animation frame, which would run at the display refresh rate, so usually 60 Hz. What they've done is creating a VR display request animation frame, a dedicated request animation frame for your device, which runs at the expected frame rate, which in this case is 90 Hz. So you would use this one, not window request animation frame, but your display request animation frame, and loop there with your callback. And then in the callback, when you do the get pose, do all the calculations, call the renders, then you call VR display, submit frame. And if you have a pose because you're doing the prediction, you put it there. So that's basically how it works. Then when you want to stop presenting, you can call cancel animation frame from your display and exit present. There's a few window events that are interesting, which tells you when a display is connected or disconnected, or when the presentation changes, and then you can decide what to do with that. But basically, sorry. Okay, I skipped one part. Let me go here. Okay, so all together, again, get the VR displays, so you get the list, you choose which one, or let the user choose if they will add more than one. Create the canvas, the element that is going to render content to. Use request present to tell it, I want to present on the HMD from this canvas. And then create the animation loop using the display request animation frame, loop over that, getting the pose, perform the calculation rendering, and then using submit frame. So it gets passed to the screen. And what I was saying here is, what about input controllers? Input controllers in this version of the API were moved out of the spec and moved into the gamepad API spec. So they work as any other gamepad controller. So your solution, I mean, in the end, it's more helpful because maybe you can set the same thing with gamepads or with any other thing. But basically, the way you do it is you hold your VR gamepads in an array, which after the calling navigator get gamepads, you have to go through all of them, check if they have a gamepad and it's a gamepad pose. Ideally, those will be the ones from your WebVRs, the sensors. So when you're animating, and you keep it, and when you're animating, run across all of them, and then check it, and you can have pose position or pose orientation. So it's a 3D vector, it's a 4-component quaternion, and the buttons are ready. And then it updates. And I think they update now at, I think they update at 100 Hz or something like that. They update faster than the display rate. So then you can basically read the orientation position and what's the status. And each button works as an analog or a Boolean or whatever. Word of advice, the devices only appear, the gamepads only appear when you press a button, first time. If they are not detected otherwise. So that's, if you're trying to get a controller in Sonar Team, you know it's because of that. Okay. So, but you don't have to worry about most of this because there's 3JS. I'm running too low. How are we doing in time? Okay.
It's okay.
Okay. So, 3JS from the beginning offered the VR effect and VR controls, which help you skip all that and use it directly. So, when you code 3JS, how many are familiar with coding 3D graphics with 3JS? Okay, I'm going to show you. Okay, then you might not see the whole difference, but you create a renderer, and it's going to be WebGL. You attach the canvas, so it's on the page. Create a scene, which will hold all your geometry and all your actors and everything. Create a camera, which in this case is a single camera with the perspective and everything. Create controls, which in this case are like mouse and key. And create your geometry. This is like a random function. And on your render loop, call the request animation frame of the system, update the controls, and render your scene. That's what you do. Okay? That's the most basic example of anything. And the same thing with, what is this? With WebVR, it's still create the same render, attach it, create the scene, create the camera. The controls are in this case VR controls, and you specify which camera you want to attach to those controls. So when the HMD moves that camera, and create an effect, which is a 3VR effect. Specify the render, the size, and the rest is the same. Create the wall, create your render loop. And instead of calling render, you call effect render. So it's going to take care of the stereo rendering and everything. And the other thing is like you usually start it with some user action. That's legacy from the old API in which you needed some action to start the full screen. The full screen and the WebVR API were kind of together because you were presenting your screen. Now it's not necessary, but there's still the enter VR, you know. Most experiences are still like this. So things to remember, this is very important. In 3D units, 1 unit, it's 1 meter, right? So everything you do, 1 meter, 1 unit is 1 meter. So if you think it looks okay in my 2D and I turn it to 3D, it will probably be wrong because you might see it right, but maybe your chair it's actually 200 kilometers tall, and you are actually a 200 kilometers tall individual. So it's 1-to-1. If you want to create a box which is half a meter, put 0.5, and then everything will work. If you've got running into problems in which you seem like you're seeing, it's like you're looking into a diorama or you're like super small, it's because of that. So that's one thing. Don't ever move the camera. This is more like general solutions, but don't ever move the camera unless it's initiated by the user. Even if you think it's slow, it's quite slow, I'm kind of gliding the user across the scene. It might not affect you, but it will definitely make someone dizzy. And it's difficult to get out of that. So that's another thing why the latency is important, because basically if your code is running slow, the reaction to the movement is going to be slow too. So they're going to have this dissonance. So if you are like after a long time trying this, you will just feel like a bit upset if you get like a really heavy motion sickness, but most people are probably, I can tell you. I mean, you can say, we've been doing that, it's not that bad. Someone tries it and might even faint because it's really bad. So same thing, this is more or less the same code for the cardboard. I don't know why it's... So still same thing, just the difference is that the controls are device orientation controls and the effect is a stereo effect. But this will also change when everything comes together. And then still you will have a single effect that will render through the WebVR. We're waiting for everyone, like Firefox to also release a WebVR 1.0 version, so everything is up to spec. So now that we're on the topic of cardboard, there's more of them. As Martin was saying, they're really accessible, they're really easy, they're really customizable. You can put your phone now, there's a lot of phones. There's even plastic ones that can change sizes, so you can put your big iPhone 6s or something. But they still have all the limitations, so like the keeping the screen awake, dealing with touch, they're really not fast, or maybe what you're doing on an iPhone 6 runs beautifully, but it dies on an iPhone 4, you know? Lens distortion, for instance. You can tell which viewer you're using. So the cardboards have usually have a barcode, a QR code that you can read, and it will give you the information of the lenses in the viewer. But when you put your phone, the system altogether doesn't know the dimensions of your phone. So we still haven't figured out how to make that easy. So if you put an Exos 5, it will probably be all right. But if you put a 6P, it won't work, or it will look weird. Sensors like lots of things, how to integrate the Tango system when it works, when you know what releases it. So due to this, there was the idea of making the responsive WebVR by Borismus. It was like try to make right once and it works across all devices, you know. And he created two things. One is the boilerplate, which you can use if you want to start a project. It basically adds all these different cases and all these different situations. It adds the polyfill for the systems, all this weird situation in which a browser doesn't have support or has partial support, or you want to build just for WebVR, but you want to have a mouse in your screen if there's no sensors, and the manager, which basically gives good practices of placing the full screen button or the go full screen go VR button, anything like that. This is input devices. So besides the API, as Martin said, there's the link motion, there's the Mio, Mayo.
It's weird.
It's really. Do you do the?
Yeah. So I tried to do a presentation with it, and it just did random shit at random times.
It's something you put here, and it reads your electric signals. But to like say I'm resetting, you have to do this. You have to.
You have to like do this and then that, and it has to be in a certain speed, and it has to be in the right angle. And
you have to
like this, it doesn't.
You have to turn like this. On my
version, you have to do like this and then that.
Something like that. So it's very stupid because you're showing a demo. It's like, yeah, this is it, and this is not flying. It's like 1 second.
Out of 10 people that tried it in our office, 2 could do it. Me and a friend.
Good comment from as well.
If you know how to So, but you can bring gamepad controllers if you want to fly. You can bring any other device for your interactions. I don't know. I can show. This, for instance, it's something that works with the scroll, so you can look around. And of course, it's absolutely not compelling on screen because the funny thing is to see it on VR. But anyway, so cardboard. I think we've talked about it. On top of transforming the camera, this is interesting. Usually, when you attach your camera to a control, like this, controls in the 3 controls camera, it will put your camera in the point that the sensor is placing, that it's basically the origin. So it will be on 0, 0, 0. So if you have a scene and basically you put like your ground is here and you put your camera, it's going to be right there. So if you want to move it or you want to put an object and rotate your camera, you have to create a dummy and add the camera and then move the camera inside the dummy. So what's going to be moved is like a relative system. You're going to be moving this, and the camera is going to be here. So this is an interesting thought. So if you try VR, there's like, for instance, the many demos. Like the things just go right through your head. Like the Vivecraft, there's a Minecraft clone. You go into VR and suddenly everything is full of blocks, and your head is inside blocks, Or you're in a room, you're playing, and suddenly, of course, like the room virtually finishes here, and then you can step into the wall and look what's outside. And people react really badly to that. Some people don't really mind it, but some people get like I think it triggers some kind of claustrophobia reaction or something. So, advice in this case, try to detect distance to near objects and fade them out, if you know how to do that. Or what I do is basically, if I have physics, there's like a banding volume around the head, and then everything like bounces out, which also creates like an interesting interaction when you're walking things up, floating out. But consider this thing about VR proxemics, which you don't know a lot about, which is people like, they are like in a game, in a 2D game, in a flat game, like we call, you probably don't react entirely to enemies coming at you, but in VR, you're literally there, so your personal space and your social space and everything still holds, So if you try those zombie games, you're probably gonna crap your pants because literally you're gonna feel like someone's getting into you. And there's nothing you can do to solve it. And I think that the problem is that at the same time you're thinking, I cannot run away from this because I'm gonna smash my head against the wall. So your flight or fight response, it's completely messed up. It's completely messed up. So when creating these kind of things, like all these games in which you are shooting from like they're hovering, and those are fine. Like outside maybe 4 meters, absolutely fantastic. When they start getting in your personal space, things get really, really complicated. Okay, so 3D sounds. Yes, we have 3D sounds because we have the Web Audio API, and then you can put a spatializer on the sounds. There's lots of talks about this. It does work on the cardboard, so it's interesting if you want to create a compelling experience. Like all this simplicity of having just a flat panorama or just not being able to move around with sound improves a lot. There's all these binaural demos that you can try. So general VR lessons. These are more general. These are not entirely related to WebVR. So, but as always, like try to offload calculation to vertex shaders as much as possible. So basically, everything that you can do on everything on CPU that can be done on GPU, do it on GPU. And everything that it's done per fragment, so for each pixel on the screen, and it can be done on the vertex shader, do it on the vertex, because basically you have way less vertex in your geometries than pixels in these massive screens, because these screens are insanely dense, and they have to become even more dense, so we can see like really, really good. Instantiate if possible within reason. So basically, it's interesting to like not having. Think that you have to, when you're rendering twice, you will be calling twice everything. So everything that optimizes that, it's an interesting game. So instantiating helps, but you have to know what you're going to be instantiating, what you want to repeat in each eye. Downsampling is always an option, which means that maybe you want to run at the display maximum DPI or resolution, but maybe you won't run for several reasons, basically because of fail rate. You can downsample, you can make it more pixely. People might be okay with that, you know? It's more important to have responsiveness than they have sharp graphics, as long as they are not super blurry. With cardboard, another interesting lesson is to pre-distort the geometry in the vertex shader. So instead of drawing everything into a texture and then that texture becomes distorted to compensate for the lenses, this has two problems basically. WebGL doesn't allow anti-aliased rendering into render targets, so it's already pixely, and you will have to run as maybe some fast approximate anti-aliasing or something which consumes more time. And then when it creates that distortion, it becomes even more pixely because it's distorting places in which there's, like it's enlarging some pixels. So if you try to pre-distort and account for the distortion of the lenses in the vertex shader, it's easier because you can have more vertices than trying to make it on the, it's related to the first point. So you then would render directly, it would look fine, it would have multi-sample anti-aliasing, and then you could have crisp graphics. And then when you do that, of course, then some things don't work really well, but you can place your text or your UI with DOM and CSS in the center, around the center of the eyes, just as a regular layer. This won't work when we get the WebVR final implementation because it's going to probably just take a canvas. But for the moment, this solution is what gives by far the best experience in cardboard. Like things look really, really, really good. And in general, people expect feedback from everything. If they are able to move, they're able to. I mean, first they expect to be able to interact. So all the platforms that don't have input controls, it's okay. But the ones who have, they expect them to see them and the world to react. It's first nature. So haptic feedback. There's still haven't settled down in a specific way of handling vibration. There's a vibration API. There's gamepad controllers have a vibration API. They're working on that. Physics, usually that works really well. That's most of the VR experiences right now. Nowadays are physics sandboxes basically. Frameworks and libraries that you can use. There's 3JS, which more or less you have to code most of the stuff. I mean, it gets a lot of things out of the way, but you still have to create your instances and move them around. There's A-Frame, which it's based on a more simpler approach of using declarative HTML-like language. So you build your scenes with HTML. There's a very clear structure and how things interact. So it's really nice if you want to start with that without going right into coding everything. A-Frame, it's basically markup working on top of 3JS, which works on top of WebGL and WebVR. So in the end, you want to decide how far up or down you want to move. Apps and platforms that you can use. There's Play Canvas, there's Visor, Archeologic, Sketchfab. All these have solutions for creating content that can be consumed in VR or just consuming content in VR. So they're still working on this. Play Canvas has a very nice solution for that. Visor is completely oriented to create VR experiences. So about tools, and then it's when I can talk about the WebVR API emulation extension. So for things like this, in which there's no hardware available, I created this extension. You install it on Chrome, and it will kind of create all the base for the WebVR API if it's not there, and it will create a fake display that you can move and rotate and move around in the panels. So I can show you here, for instance. Let's say, let me show you. Okay, so for instance, this, I know it doesn't make sense because it's flat, but anyway. So this is loading everything. It's running with the WebVR manager. So we have here two buttons, full screen and go into VR. So as I was telling you before, my head is right now on the floor, so I'm looking that way inside the floor, and I cannot move. If I had the Vive connected now, my head would be here and it would be looking correctly. But what we can do with this is going to the WebVR extension, which shows you this, and then I can move the camera, and then I can look around, and it's more or less useful. And then we can try the, okay, then it's the stereo. You can try everything without having it. So I've clicked, and now it's rendering in stereo. This is what would go to the HMD, and that's basically it. But it helps a lot with the. You want to move, you want to take things around, you know. It's basically replicating what all the information the HMD is sending, and we can use it with anything. So in case you have something and this will like save your ass if you have to show something and there's no HMD. It's on GitHub, it's open source, so everything that you want to get there and use or expand, there's an idea to add the controllers, for instance, so you can interact, and there's lots of ideas to do that. Cool. So challenges for now and the future: rendering under 20 milliseconds latency, rendering at 90 Hertz, which is like 11.1 milliseconds per frame. It's insane, but it can be done. Decide if we need a declarative WebVR completely with HTML, CSS. Maybe we don't. It seems like we won't. Just everything will be just canvas. There won't be use of what we understand now as the DOM. We need more tools. We need more libraries. We need more use cases. All these kind of patterns of interaction that we're going to be finding constantly of how to do things in any case, because you're going to be finding your use case and some need for some interaction that it needs to feel familiar. You cannot explain lots of things. You might put lots of explanations on when the user does some gesture, because you have gestures now with the controllers. Security concerns. There's all this discussion about the WebVR being SSL only, just for secure origins. Everyone has an opinion. I think it makes sense in the way of pushing everyone to become more secure and having encryption enabled everywhere. One could argue, what's the risk on having a non-secure origin or a man-in-the-middle attack on VR? I don't know. Maybe someone injects something on your VR world and gives you a heart attack. There's possible real security problems. And that's basically it. Last time there wasn't a lot of power, there wasn't use cases. Everyone had their kits, but there was no consumer base, there were no use cases, and suddenly now there's a lot of hardware. The consumers are getting them. AAA studios are starting to do things. Industrial Light and Magic is showing stuff. There's going to be movies. There's going to be lots of stuff. So even though it's growing steadily and this is becoming more mature, there's still a ton of content. There's still a ton of things to do. So it's truly a new world to invent. Go and create, and yeah, that's me. Thank you. I wanted to show. Let me show you something before the demo I wanted to actually bring, which is the physics. So, okay, imagine the network wasn't really laggy. Okay, so this one interesting case. Okay, and I don't know if someone still has it on on another platform. So there's this. Let's remove the advanced mirroring. Let's open the second. Let me. It would have been so much easier. Okay. So. So this is like a. Okay. So lots of shapes that basically bounce in low gravity around you. Okay. So if you go into VR, you can look around and you could use the controllers and like make things bounce and interact with things, and it's really nice. I mean, it's what you expect. But there's this thing. So remember that I said that there's this on your request animation frame. There's this submit frame, and it's like when I've drawn to this canvas, I submit it, and then it's shown to the HMD. But that doesn't mean that it's the end of the story. There's this thing called advanced mirroring. So if you don't do advanced mirroring, and after rendering your canvas and calling submit frame, what you see is this. You see what the HMD is going to be seeing. But if you keep on working, clear the canvas, and render another thing, you can basically okay, so now I have a camera that is looking at the scene. So if I had a real human interacting with this, you know, I would see how he's moving in VR and what he's doing, you know, what they're doing. And actually, in VR, they see me as a camera floating in front of them right now. And then it makes the question like, can I interact and throw stuff at the guy, you know? And then he could react. And then you can actually create an interesting dynamic, which is you have, I mean, if someone was here playing, I would be shooting things at him. And he would sit there like, which is pretty funny. But it's an interesting dynamic. I mean, of course, this could be multiplayer, and then you could have people connected. But this is actually like when you're working on the same place. So all these things about VR being antisocial and everything, you can consider that there's a way of having someone playing with the people in VR, you know, just like making some obstacles or creating something. Or that's the thing. But that's the interesting part. So you can render what you're seeing in VR, sending it to the HMD, clear, and draw from another camera. It's an option, and it's pretty cool. And in this case, all this demo, it's built with again with 3JS, very simple code, like a library for physics and the WebVR manager, the WebVR polyfill, and it really works when you have an HMD. So, thanks. That's me. Questions or have time for questions?
Yeah, sure. But are there any questions?
Are there any questions?
Oh,
can you?
What is the version in Samsung Internet now for WebVR?
Sorry?
The version of WebVR in Samsung Internet now on the Gear Zero?
I think it's probably pre 1.0. It's the regular one. Well, the thing is that so the gear, the internet, that thing with here is that they are trying to keep up, but they have. They started before the WebVR 1.0, so now they're kind of catching up, but first they need it to work. The thing is that Gear, since they allow to install applications, most people what they're doing is trying to create their own render of JavaScript with their own applications. So they're skipping the browser altogether and creating like a 3D WebVR player. But I think Samsung Gear, it's like everything in Samsung Gear is still the pre 1.0. So right now you might find lots of content which kind of doesn't really work because it's in this flux of the API.
You have a time frame when most browsers will support this?
Yeah, no, the idea is that that's the spec and they'll support it. As always, the browsers do their thing. So Chrome and Mozilla are entirely committed to that. Both have resources and teams working on that. Apple, one never knows. And internet, like Edge, have other priorities yet, but eventually they will come around because they have WebGL. So ideally, everything except iPhone, all the platforms have. Okay, most platforms that run on Windows have the option to have WebVR. That's not a problem. So Edge can have it, and I don't know what else is there. You have everything. But Apple has a different problem because the SDKs don't work on Apple machines because they deem them to not powerful enough. So there's no way to do that. Maybe with the OpenVR can be done. Maybe they'll reverse engineer the drivers. That's one thing. So it might work. There's the chance. Or they haven't said, like Oculus haven't said that they're not committed. They said that they had to put all their resources into Windows. Maybe when they're done, they will go back to OS X and Linux. But Apple have their own, I guess, projects, which nobody knows about. And iPhone is not really, the iOS is not the platform for this. So let's see what they do. Maybe they come with a Daydream alternative, but doesn't seem like it right now. So right now, if you build something for VR, specifically cardboard, Android it's pretty cool. iPhone is, depending on what things are pretty bad. Video, lots of things. So it's difficult to sell good projects to customers that won't support with iOS, and it's difficult to compete with a native app. Because in the end you're building a lot, like you're dedicating a lot of effort to both websites, both versions.
Yeah, I was wondering if you were stressing during your whole presentation that actually the reality of virtual reality is not that important. The immersive part that it reacts quickly is way more important than anything else. So coming back to that, is VR a good name for this technology?
What do you mean?
Should it be called virtual reality? Is reality?
I mean, there's, I get what you mean, but I mean that's the term we. I mean, it comes from. It's like a heritage. We don't get to decide on that. Maybe there's hybrid reality, there's mixed reality, there's augmented reality, there's virtual reality, and there's, I guess, real reality. I don't know. At some point, you have to wonder. But this is specifically what it does. Like create images so they replace your input.
Oh, okay, of course, I understand the history of it, but at the same time, giving something a name also projects the use of it.
Mm-hmm. Any more questions? No. Oh, it would. Yeah, sorry. It was planned with someone doing funny things here while I was talking, so I'm sorry. It was a bit too dry with examples. But yeah, that's one important thing. You cannot develop. I mean, you can test VR, but you cannot really develop without one of these things. Because, like, for instance, like creating graphics and watching them, it's okay. But once you start working with interactions, like let's try working with input controllers, there's literally nothing that you can do on your computer that simulates the 6 degrees of freedom in VR. So basically, you know what? Yeah. Okay.
I have one more question.
Yeah.
What do you recommend, if guided, you recommend for who want to start developing for it? I want to start develop for play, like a hobby.
Mm-hmm.
What do you recommend to start, like the Oculus or which one do you think is? You think there is one it's easy to start, or it always depends?
Depends basically on your budget.
Okay.
Right now, it's basically that. The rest, like the software, everything is open, everything it's cool, but you probably have to spend some money on a computer, and then it's between 600 and 700 euros. I personally recommend the Vive. I mean, the Oculus is probably ergonomically and maybe technically better, but the Vive does something that the Oculus cannot. And you can have room scale, and the Oculus doesn't. So Everything that the Oculus does, the Vive can, but everything that the Vive does, the Oculus can. Right now. Let's see in a few months when they show different constellation sensors. Sorry, if it works. As it is right now, I think for a developer, the Vive is much more appealing. And it's backed by another super closed company. If you catch my drift. So it's more, things are more open to change. Like for instance, so Oculus doesn't allow third party, like there's all this mechanism for third parties applications to run from the Oculus SDK. If they are not enabled, they won't run. So you have to go, and it's like in Android, you have to go enable third parties. It's like 6 clicks. You have to do it at least once. But if we're already saying all this, what Martin was saying about trying to make it work to show to a client, and you still add to that 6 steps in which you have to go until it really runs. So all these kind of things affect the deployment of your solutions.
I haven't heard HoloLens debate. How does that fit in all of this?
HoloLens, I mean, that's more augmented reality or mixed reality. So no, but still everything that you've seen, it's kind of there. The only thing would need some way, like in VR, everything is designed to draw everything on the canvas and then get displayed. With HoloLens, there would need a way of getting the 3D information and how to create the masks or something. It's opaque, probably like reading the alpha channel of your canvas. I don't really know about that, but it could be connected. It's not entirely different technology. But basically, right now, Microsoft is completely dedicated to Unity on building software for the HoloLens. So again, maybe someone in Microsoft or the Edge team gets. This is all basically people's personal hobbies, personal projects. Like I'm gonna add VR to the browser. So maybe someone in Edge says I'm gonna WebVR, and since I have a HoloLens, it will work with HoloLens stuff. But no, I don't think there's any word.
Right? Yeah.
You may often run into a situation where you're putting on some kind of headset for the first time in your life, while somebody standing next to you is trying to explain how everything works and what you can touch and do.
Yeah.
Is there already a thing like turn on the camera on the back of your telephone mode in which you can see the actual reality without having to put off that thing?
With cardboard.
Yeah, is it already there?
Yeah, with cardboard you can do that because you can get user media. There's the gear does the pass-through too. The problem first is that you have monoscopic vision because it's one camera and your vision is like up here, so it's a bit confusing. That works and you can do it, and then you can do augmented reality actually. Like what the Tango does, you can do it with an Nexus 5 for instance. It's slow, it's laggy, but then you can kind of detect markers and bring content and things like that. It's pretty slow. It can be done, but it's pretty slow. I mean, you can download that downsized video and place it. But yeah, I mean, with the cardboard it's not a problem because you can basically, the cardboard is just like this. These are a bit more complicated because you really have to tie to your head. There's the Tron mode. You can watch through. There's this kind of lines. I know you've seen it. So there's a camera and it shows like a wireframe, like an edge detection version of your surroundings, so you can kind of touch things. But yeah, there's other ways of like you can type. The same thing with the advanced mirroring, you could type into this screen and they would see it. Because sometimes when they're using the headphones, they don't hear anything. It's like, go to the left, go to the use the sword. Yeah, so it's means of communication. But yeah, but this will improve. I mean, this just think what 5 years ago. Not even that. I mean, it's insane how these things are evolving. I don't know if they will stand like plateau or something, but they're gonna They're getting pretty powerful. And with the Lenovo ones, maybe we'll start seeing phones with 2 cameras. Not 2 literal color cameras, one with infrared, the other one with color, but Tango and that would be cool. And supposedly some other people are working on inside-out tracking. So we'll see. Inside, so this out-inside tracking. So you need stations. Inside-out is your device can tell where it is. So Tango, by knowing the surroundings or optical flow analysis or something. We'll see in a few months or years.
Okay. Well, thank you very much.